This is tutorial third of Cadence Virtuoso IC615. In previous tutorial, I showed you how to create a symbol and how to use the symbol in different schematics. In this tutorial, I am going to show you how to use a calculator in Cadence Virtuoso. So again, I will be launching ADEL, and I have saved the state previously. So I run it. So these are the different results. This is transient response, this is the VTC curve. So first of all, if I want to see the rise time and fall time of the output, using this I'll split it. Okay, so this is the zoom bar. I'll bring it close. It will show me some there because of the capacitors present. As you can see here, it will show me some rise time and fall time. So for this, what I will do, there are different ways to launch calculator. First is I'll go here, tools. This is calculator. This one is, and second way is to go to this results, sorry, tools, and you can launch here calculator. This one is, and third way is you go to your where you define your outputs. You go there, and there is this option calculator. You open it. Okay. So let us say I want to check the. Okay, now here, when you are doing transient analysis, for that transient analysis you have to choose VT. It's for voltage VT. Like for example, in my circuit, I want to write one expression for this V out. So if I'm doing transient simulation, so I will take VT, and similarly for current is IT. This is for AC simulation when we are checking some AC response, and this is VF, and similarly this is for VDC, and this is for DC simulations. And these are for operating conditions, like I want to give some expression in which I want to define VTH of my transistor, etc. And these are for RF design. So for now I'll show you some basic recording inverter, like in mostly in transient simulation. What we see rise time, fall time, delay, like that thing. And whenever and one more example I'll be showing when I'll take AC response of some. I'll take one common source amplifier. So for now, so I'm interested in seeing the delay, rise time and fall time of my output. This is the output red one. So what I'll click on this, and I'll send it to calculator here. Okay, so this is one way. Another way is I'll open the calculator here, calculator anywhere, and what I'll do, I'll press this off and wave. I'll select wave. When I'm selecting wave, and then I'll go to my this window, and I'll select this. When I'm selecting this, it should automatically come here. Okay, so it's coming here. Okay, so it's like that. So there are different ways. This is for transient simulation. Okay, so I'll be sending this again. I'll send this to calculator, and now for giving any function, like I want rise time. Okay, so you type rise here, it will show rise time. There are all the functions are here. If you see here, it's like 1 by x is there, 10 raised by x is there, everything. If you, for example, fall time, rise time, delay, you want to take a Fourier transform, you want to take a power average, anything you want to, bandwidth you want to calculate, UGB, S1, S parameters you want to calculate, jitter, noise, and everything you can define here using expressions. So for now I will take rise time. Okay, so this is the rise time. So my signal is output signal, this one, and I will define here some initial value and final value. Since it's 0 to 1.8, I'll take 0.1 to randomly I will take 1.6. Okay, this is for y-axis, this is not for x-axis. Y-axis is the voltage, x-axis is the time. Okay, I'll just okay it, and since this rise height will be a numerical value, okay, I can't plot it. So for plotting it will give me here, okay, if I plot, and for numerical value I have to press this one. So this is the rise time. You see here, this is the rise time. Now this is first time. Now in future, if you want to, like, every time whenever you do your simulations, you want to display the rise time without going to calculate again and again, you can just press here. This is, it will send to the ADL, okay. This is one way. Other way is, you go to your ADL window, go to this output value you choose, and press this get expression. So it will come here. I'll just give it it's rise time, okay. I'll press apply, okay. Similarly for like your fall time, again I can give for same, okay. I have to change this thing here. Fall time for this, I'll take it from 1.6 to 0.1, okay. This again, since it will give some numerical, I can press on this, it will give me fall time, or I'll send it to buffer, like in this I'll send using this, so it will automatically come here. I'll give it name fall time, okay. Apply, okay. So whenever I do some simulations without going to calculator, okay, it will give me this result. And if you see this window, ADL window, it is giving me here numerical values of my fall time and rise time. So every time whenever I will doing transition, it will show me here rise time and fall time. So this is one way. This is how we use calculator for transition simulations. And now if I go for this, I want to see this point, this joining point here. So this is simply, I can take derivative of this one. It will show me the maxima and minima. So what I'll do, I'll send it to calculator, okay. Calculator, I will take derivative. I'll take derivative of the signal, and since it's a continuous signal here, if you see here, it's a continuous signal here, okay. So what I can plot it, okay. If I give it will give me a list table, okay. So I'm going to plot it, and it's giving me, this is the maxima of this. So this is the derivative of my output curve, okay. This is the point it meets, like here. So this is how it is for transient and DC things, okay. One more thing is there. I'm going to, again I'll launch calculator here, okay. So now let's take, I want to display some DC operating points. I want to display some, I'll go off and I'll tag this OP, okay. And once this OP, this window will pop up, select an instance. So I'm going to choose which transfer I'm showing, like I want display ID, or I want to display VTH or something like that. I'll click this one, okay. Once I click this one, it will show me all the operating points of my transfer MP. So let's suppose I'm taking VTH, okay. Where is VTH? Now they will find it. Should be here. Okay, let's suppose it's, yeah, okay. So this is how. So VTH, like now if I want to, like divide the VTH of M1 divided by VTH of M0, so I have to again select one more transfer. So again when I'm going back, like I have to, this is for every expression, like if you want to divide or minus or multiply or take Fourier, take derivative of two waves or two signals, two nets. So once you select one, it comes here, you just press off, again you select this OP, in case this, and I'll select this one, and again I'll select VTH, okay. So now this thing comes. Now I have to minus these two, or I have to divide out. I just let's put, I want to I want to subtract these two. Okay, I'll press minus. Okay, so this is minus, since it will give me also a numerical value. Okay, what I'll do, I'll just send it to the buffer. I'll send it to the ADEL. Okay, so it is here. I'll write it VTH. Okay, it's a DIFF difference. Okay, so now if I run it again, give me here, see, it's giving me the difference between two VTH, that's VTH of this M1 minus VTH of M0. Similarly, like you might have learned about the GM by ID method, which we use for design techniques. So that also you can define here for a simple common source amplifier. Okay, so this is for inverter. Okay, so what I'll do, I'll take one arbitrary common source amplifier. Okay, so I'll take this one only. Just what I selected it, C is for copy. Just click on there and go wherever you want to go. Or okay, so I'm selecting this one. Okay, and let me delete this one. This is in. So this is a simple common source amplifier with diode connected load. Okay, so I'll do check and save. Again I'll go here, and for now, first of all, I'll give one AC signal here instead of transient. I'll give a DC signal. Let's take 0.8, and I'll give some AC magnitude. Okay, so that is enough for AC simulation. And I'll select all these, and I'll do disable plot, and this is not required for this, and I'll do AC simulation, AC, and I'll vary the frequency from 10 to 10 gigahertz. It's asking here automatic or linear or logarithmic, since it is okay. By default it will take logarithm because of the range I'm giving. Okay, so this is it, and now if I run this, okay, so the first thing is I want to display the gain of this thing. What is the gain? Okay, first the operating points. I'll just go here, annotate TC operating points. This now, if I want to see region or any operating point I want to display it, just go here directly and click on the transistor, or you can just press it. Okay, and similarly for NMOS. Yeah, I'm not designing this common source amplifier. Maybe later on I'll show you the procedure. For now, you just remember the thumb rule for designing any amplifier is, the basic rule is that everything should be in region 2. Region 2 is active region. So now I want to plot this gain. So there is one way is, it is a utility here. It's actually calculator thing, but they have just put one shortcut for this. It's here, that plot. If you see here, it is AC gain and AC gain and phase. Okay, so I'll select this, and I'll select the output, and then I'll select the input. So this is giving it. This is not required. Yeah. So this is, it is having 10 dB gain, and this is phase response. Okay, this is gain response. So like that. Now one more thing I want to do is, I just want to put one capacitor, load capacitor, so that the bandwidth will be decreased. So I'll go here and I'll press unlock lib. Okay, this is unlock lib. AP. Okay, I had to write it small. CP. Symbol. mistake, I took 2 picofarads. Okay, again I'm saving it, again I'll run it. So once the run is over, again I'll go here, direct plot AC gain and phase. I'll click on this and input. So this is gain and phase response. Now this is one way to plot this gain. And now if I want to go for calculator, like okay, I'll use these two only, AC gain and phase, output divided by input. I'll send to right click, I'll send to them ADL, ADE. Okay, this is here ADE, ADE. Okay, okay. Now if I see ADE here, I'll delete. Okay, this is gain and this is phase. Okay, so I'll just run them. It will show me the AC response of my this common source amplifier. This is not for inverter. Now what if I want to see the bandwidth of this signal? So what I'll do, I'll just select it, I'll send it to calculator, or I'll open calculator and I will press this off and wave, it will come. So again I'll do function, all function here, I'll type bandwidth BAND, it will come here bandwidth. So it's asking 3 dB low, yes, okay, and it will give, since bandwidth is numerical, again it will give some numerical here. So the bandwidth of it is 25 megahertz. Okay, now for future I can just send it to ADL bandwidth. Okay, okay. Now one more thing is there, if I want to see similarly gain bandwidth, if you see the function here, I'll show you. There are a lot of utilities here, you can explore them, and whenever like if you see here, you can also find the unity gain frequency. You can also find the phase margin here, also phase degree, phase margin is here. Okay, so this is how we use calculator for AC simulation and DC simulation. Okay, so now I'll be going for layouts in next tutorial. So this was basic overview of calculator. And in future, whenever I'm going for design, I'll be using this calculator more and more often. So you'll be having a lot of expertise in calculator also later also.